I'm really happy to be here at JOTB17, and today I'm going to speak to you a bit about Together Bank, which is a fintech company, which I'm going to tell you a bit about and how it works and what it does. And in Together Bank, we've developed an informational system based on big data, and I will tell you all about the architecture and different technologies we are using and algorithms and what they're used for. So, starting first with Together Bank, and what's the business model? And the thing is that finance is one of the areas that hasn't evolved much in the last years. And if you think about new companies where the user is the main point of the business model, such as Uber or Airbnb and so on, you see that the business models are evolving, and finance is a model that is still stuck in the past. And Together Bank is a company that is trying to fix that, or at least propose a new business model based on financial services. And this main model is based on having a banking infrastructure where you have your basic core model, core in terms of you have a savings account or a deposit account where you can save your money and have your money available for you. You have a debit card that you can use for payment. And besides that, you don't really need much. So what it does is try to provide that infrastructure, have just the basic things for the user, and around it have a lot of APIs and a lot of ways to communicate and use other fintechs so that they can provide different services, and other finance institutions such as banks so that they can also provide services for the end user. And besides traditional financial products, what it's also providing is a way to tokenize other assets, such as electricity or gas or any other asset that can be traded, so that we have a marketplace, a way to put in common not only financial products, but also other kind of assets. And getting to the technology and about the global technology, and not just the informational system, the way it does that is by integrating, and let me go to architecture first, I'll go back to that part later. What it does is have a transactional part that is based on blockchain. The technology beyond it is the Ethereum blockchain. Probably most of you already know about it. And it's basically based on smart contracts for communicating with other parts. It relies on a banking API. We have a bank that is providing the banking license for having deposits and the accounts and the credit cards and so on. But what it does basically is having a transactional part that is based on a private blockchain that relies on a public blockchain just for security purposes and reliance and so on. It has a main backend which communicates all the parts, and it has a big data layer, and we will get into more detail about this part and how it works. And it also relies on some cloud APIs, which is the way that other fintechs are communicating through the system. So basically what it does is it provides a smart card. This smart card can be used for paying at any commerce, but also for using any tokenized assets. For instance, you can go to a gas station and you can have your gas available or already pre-purchased in your credit card, so you can use it to pay and have your liters or gallons from gas be taken from your gas account. And from the API, it also has your common accounts and other payment networks for doing transfers and having your IBAN number and so on. The blockchain part is based for first tokenizing our own currency, whatever fiat currency, such as euros or US dollars or Great British pounds or whatever, is first tokenized in the system. So we have our own currency within our scope. And this currency is fully managed within blockchain, so that every user has its own private key in their mobile app. And this is a only mobile app user experience. It has to have, at least not in the first versions, desktop experience, so that basically everything can be done through the web app, and you can purchase assets and have the marketplace and so on. So as for the transactional part, There are many cool features that we are implementing. For instance, anything such as a common transaction that you can do with a friend. There are a lot of fintechs that are already providing small payments so that it's easy to pay a small amount of money. And the way Together Bank does that is by having a microsite for doing a small transfer. So if you want to transfer something for a friend or whatever, you can just send a smart transfer. That person will get a web page so they can input their IBAN and so on. And basically, it's about making finance easier, easy for the final user, so that you can create your own banking experience. You can have your core model. You will do all the sign up and so on through the mobile app. And once you have your core model and you have your saving account and your credit card, you can go to the marketplace and think about the marketplace, such as the one in the Google Store or the Apple Store or whatever, and choose whatever finance product you want to have in your own banking experience. If you want to get some loan, perhaps you can get it from a bank, and you will have a set of different banks that are already interested in being in part in the marketplace. But you could also work with a fintech, or you can go to crowd lending, or you can go through any other product that is available. If you want to invest in some product, you can do a deposit in any bank that is offered in the marketplace, but you could also do that in a different fintech or go to crowd lending on the other side, lending the money. So you can create your own banking experience in something that is not actually a real bank. We don't have our own license, banking license. We just rely on a bank for the savings account and their credit cards. And that's basically it about the transactional part. It's about tokenizing assets and relying on different products. So let me get to the interesting part, which is what the talk is about, which is the big data technology. So this is the architecture that we have implemented for big data. And I will guide you step by step from all the different pieces that we have in the architecture and what they're meant for. So we have a front end, which, as I was saying before, is basically an app in your phone. You can do anything from adding a new product to doing a money transfer or managing your credit card or managing whatever is needed within your scope. We also have a smart bot embedded in the application so that for any help you may need, you can use the bot and communicate through the support through this bot as well. And this communicates to the backend API. This also communicates with the blockchain technology so that everything that goes to blockchain is also sent to the big data infrastructure. And what we're doing here is not only capturing all the transactional data, but also capturing how the app is being used. For instance, whenever a user opens the app or how the user navigates through the app, so we can have some feedback about what needs to be improved or how can we change the use of the app and so on. So this is all done through the JSON, and we have our own API, which is the main entrance for every communication through the big data layer. And within the big data layer, we first have a Cassandra core system, and we have replicated this Cassandra in 3 different parts. This is mainly because of the new regulation about the PSD2, which is a banking regulation that says that all your banking information cannot be directly accessed to your core informational system, but you need to have a replicated database somewhere else. And this is the way we are solving that issue, which is quite easy in big data, not so easy for common banks. So every transaction, every information we can get, everything that is related to our ecosystem is first sent to Cassandra, and the load part is done through Spark, and we have a Kafka system in place in order to be able to queue all the transactions. And once we have the data in Cassandra, is when the smart things become to happen. And here we have three main machine learning algorithms that are based or that use the data that is collected for our purposes. And these three main algorithms are, the first one is a product recommendation engine. We've tried to learn as much as possible from Netflix. Netflix is, you probably know about this, but it's probably the best engine in terms of recommending products. It started by having great algorithms that are based on what other shows or movies and so on are similar to the ones you have. It then added what is similar to your segment, and that means that other users that like what you're watching, what are they also watching that is not necessarily related in terms of what you've previously watched. But the good thing about Netflix is that what it then started doing is creating its own content, so that they can create content for people that will like it. And that's why you see that Netflix series and shows and so on have 5 stars, and the main reason is that they are designed for the people that they're going to offer it to, so that the feedback is great. And we've done basically a series of algorithms based on trying to provide the user what financial products or other asset products are the ones that probably match best their needs. So that when you go into that marketplace that I was telling you before, the way you will see your products are probably products that are fitted for you, and not what current banking is doing, that they're using the same products for everyone and offering the same services for everyone. You will have a more or less smart offer for whatever your needs are. The second main algorithm that we are doing based on big data technology is for credit scoring. And the thing is that we wanted to provide any fintech or any other company that uses our system a basic model for having some kind of information about the credit ranking or credit score of every user we have in the platform. And if you're not very familiar about credit scoring, traditionally there are two ways of modeling credit scores. One is the admittance model, which is the most common one used. And the way it works is that basically when you go to a bank and ask for a loan, they will request some information from you, which is probably how much you earn every month, or having your annual wages and some other information about previous credits and so on. And this is not a very reliable model in terms of it's based on a very small set of information. And what the bank actually does is once you become a client of the bank, they start doing what is called a behavioral model, which is basically once they get to know you, they know the way you behave in terms of your financial activity, how much you retrieve, how much you earn, how good per year you are in your current loans and so on. And this kind of model, the behavioral model, is much more reliable than an admittance model. And the good thing here is that what we also have is a PFM that can aggregate all your other accounts that you may have in different banks. And you could use Together Bank just for that and not have your own account. That's open to be done. So you can add all your different banks and all your different products that you have in other banks or other accounts and so on, and have a common piece for interacting and viewing all your activity. And since we can already have all that activity that you have from other financial entities and all your transactions and so on, we are able to start off with a behavioral model instead of having an admittance model. And in this case, since we were able to do whatever we wanted to do in terms of modeling this credit behavior scoring, traditional banks are enforced to do something that has data lineage and that can be explained to the regulators and that can be audited and that can be traced and so on. And since they haven't been able to use much of artificial intelligence for credit scoring, and this is one of the cool things that we could do since we are not tied to any regulation and we can do whatever we believe is best for the business. What we did is create two different models. It's actually three, but the third one is derived from the second one. And the first one, which is the main one that we are currently using and that is working so far as expected, is based on a kind of deep learning based on neural networks. And what it does is we fed it with user information about the different transactions that they have on a daily basis for a set of time. And this set of time is since they became clients of the bank that is helping us getting this information and so on. And we fed our neural network in order to be able to calibrate it with transactional movements. So we don't have much of qualitative data in our models, such as the age. Of course, we have the age, but we do not rely as much in terms such as the gender, the age, and so on. We have a model that really relies on the actual movements and actual transactions that we believe is a better approach than these kind of qualitative models that banks are using, mainly for admittance. The second algorithm that we are using, and the third one, which is kind of similar, is based on random forest. And basically, the way we've done it is similar to neural networks, about feeding it and about training it. And we will have the two models in place. We'll try to have both be available for every fintech that wants to get a credit scoring for the different clients. And we'll see which one works better. If you want to know more about these algorithms or how they're done and so on, feel free to ask at the end. We have one of the architect leaders with us, and we are at the booth, so I won't get into much detail, but feel free to ask later or to come by the booth, and we'll tell you all about it. And the third main model that we've done based on machine learning is a predictive model. And one thing that we've seen that is missing in most of the financial solutions that are currently in place is that you usually get a PFM and some kind of way of seeing how your balance is structured, or how much you spend on groceries, or how much you spend on gas, or on your mortgage, or your rent, or so on and so on. But you don't really get a feeling of how this behaves in the future, and have a way to foresee what is coming, and have a way to be taught about finance, about, hey, you have this money that is available for you, you have this kind of liquidity, why don't you do something with it? Or, hey, in 4 months, you're going to have your car insurance received, so you better start saving some money. And we've done a predictive model, and this is based on some projects that we've done for banking, for assets and liability management. And what we do is forecast for each category on a daily basis, based on all your previous records, and based on variables such as seasonality and so on that have some kind of correlation with the way you spend. For instance, your house spending for electricity may go up in the summer because of the air conditioning, and for not gas, but well, for warming up your home, it will go up during the winter. So all this is taken into account for each category, so we can project how your future finance will go. And the thing about that is that I was telling you before that we have some kind of a smart bot that interacts, so you can ask questions and so on. It's also proactive, so that if it sees that you will have some liquidity in the future, let's say, for instance, that you have an average salary of over $3,000 in your current account, it will recommend you to do something with this money, not have it just been sitting there, so you can earn something or at least get some kind of interest from it. But on the other hand, if you go into negative numbers, or it can forecast that at some point during the year you will go below zero, it will recommend you products so you can finance that part, and that won't happen to you. And this is all based on a predictive model for future cash flows. And you can actually see that model in the app. You can just see the future and see how it's predicting that your finance will go. But the tests we've done so far are working as expected, but probably will be tuned out more as we start getting users and so on. And I didn't tell you about the timeline, but we are currently doing different tests for all the components. We will be having a private beta for December this year. We have an invitational beta for Q1 of next year, and it will probably or hopefully go public by the end of the second semester, first semester of next year, or early second semester. And this is basically the three main algorithms that we have for machine learning. We have some other things in place, such as segmentation of the different transactions that you have. Whenever you spend something, whether it's with together a bank account or with account you have in another bank that is linked to our system, we have some algorithms that will try to fetch in Google what each commerce or what each record of or transaction that you have in your account is for. And we have some algorithms for segmentating all the transactions. And yeah, that's going in that layer as well. For the transactions, we are also integrated with Elasticsearch. And this is for two main reasons. One is for us, for being able to manage and to understand what's going on into our accounts. And the second one is that if you want to search for any transaction within your phone, it relies on Elasticsearch in order to be able to search for a certain transaction or a certain category and so on. This part is also integrated with Flap. Flap is the bot that I was telling you about. So you can go to your bot and ask how much have you spent in McDonald's during the last year. And this is all performed through Elasticsearch. And the bot will actually connect with the backend API and try to fetch all the spending that was done within that category or for that commerce in particular. All this part, as I was saying, relies on a different Cassandra. That part is basically because of what we need to do for the PSD2 about having a different database, but it's basically the same information that we have available here. Another layer that we have in place is Neo4j. And the thing about Neo4j is that we need some kind of AML or anti-money laundering prevention. And we've known about different cases where Neo4j has been used with great success, and we've decided to try it out ourselves. And I'll tell you very briefly about two different cases that we really liked about using Neo4j for fraud prevention. And I'm pretty sure that every one of you is aware of what Neo4j is, but just in case someone is not, it's basically a graph-based database where you don't consult in a SQL basis, such as main common relational databases. What you do to access the information is define patterns, and what you will get is a resulting graph of the pattern that you've searched for. And this works great for analyzing and trying to prevent fraud detection. And there are two main cases that have been very welcome in the market. One was for fraud prevention in credit card transactions, which is basically about finding patterns of fraud about credit card usage. And I'll tell you more about the second one because that one is not so intuitive to understand. But the second one is about fraud prevention for car accidents fraud. And the way it worked is that they were searching for patterns that would relate the driver and whoever else was in the car at the moment of the accident or was involved in the accident, and a witness, and doctors, and lawyers. And basically what you do is you have, in Neo4j, you work with objects, and you can define how they relate, but you don't do a query in terms of knowing what you're searching for, you just search for the pattern. And what they did is try to find cases where there was any kind of relationship between the doctor, between the lawyer, between witnesses, drivers, and other people that was in the car at the accident. And this was a great case. The way that patterns came out for a non-fraud subset of information were very disparate graphics, where you basically don't have much relationship between them. Maybe a doctor has been in a couple of cases, or maybe a lawyer has attended 2 cases for the insurance. But whenever you search for this kind of pattern in a subset that was a case of fraud, you will see all kinds of relationships going on. And that's a lawyer being part of a lot of cases. And in those cases, the person that was the driver in one was the witness in the second one and was within the car accident in a third one. And the same doctor attending a lot of people, and even the doctor being part of the witness subset of information. So it's a very reliable way of trying to find patterns when you don't know exactly how the information relates, but you want to find the related information. And we will be implementing that part for trying to find frauds within our scope. And we're doing that mainly because we rely on blockchain technology, and that's now very friendly for regulators and banks and so on. We not only tokenize fiat currencies and assets, as I was saying, we will also have wallets for Bitcoins, for Ethers, or if anyone is interested in any cryptocurrency, we will be able to have their own wallet within the system so that we have fiat currencies and non-fiat currencies. And money laundering is something that has been very looked into when talking about global cryptocurrencies. So it was very important for us to have some kind of AML system for being able to detect all this kind of fraud. And about the other connections we have my value for external entities transactions. And this is what I was telling you about, that within our PFM, or the information that we have within our system, we will be able to retrieve all the information that anyone may have in a different banking entity. And for instance, you have something in BBVA or Santander or hopefully JP Morgan, and you will be able to have all this information in a single place. And if you don't know much about PSD2, which is a global regulation that is coming next year, what they're saying basically is that banks must provide a way to interact with the bank for any other third party. So currently, the only thing we're being able to do is to just retrieve the information and have the movements. But hopefully in the future, you will be able to interact with your accounts through our phone app. And what I mean by that is just being able to do transactions and do more stuff than just being able to retrieve the information. And we have a third Cassandra in place. And this is for our third-party APIs. Third parties are all the Fintechs or all the other services that are provided around the Together Bank. And there was a project last year, well, last 2 years in BBVA, where they took all the information they had about transactions and about movements and so on, and they took out all the personal information, and they made this information available for universities and for other people to study. And what happened is that all these people came out with a lot of new ideas for products that could be offered to their clients. And this is great, and we want to share this information with different Fintechs. And what we're trying to do with that part is have all the information available, first through Cassandra, but we will be adding flat text downloads, and we will be adding a Tableau server for Fintechs that are not so tech-savvy in terms of using a Cassandra database. So they can look into the information, and they can design new products, and they can see what the customer actually wants and how the customer behaves, and try to come up with new ideas. And I'm being told I have around 10 minutes, so let me wrap up this very quickly. This is basically a bank without being a bank. And for the transactional part, it's all based on blockchain. Sorry that I didn't have time to get into that part very much, but if you want to know more, feel free to come by. And for the information layer, we believe in having just one global layer. This is not being done by any bank. Hopefully it will be in the future at some point. And what we want to do is to bring all this new technology to the financial services. That is something that has not been done, at least not yet. And Well, yeah, this is basically the architecture we have in place. I'm also sorry not being able to get into much detail of the different algorithms and technologies, but feel free to ask if you have any questions, or if you don't want to ask now, feel free to come by the booth later.
Some questions?
Hello. You spoke about the credit search. And the API you use for your products if they're going into negative ratings or money. Do you take into account the footprints that are done for the credit searches when you're machine learning?
Well, what we've actually done is that the bank that is providing us the information, we have data that is about people that have had a default, so that we know what movements they've had previous to that default, and we can relate that to a default pattern. And we have some information that is related to non-default people. That is the ones that we are using for training the neural network. So it can be seen as kind of a footprint, but I wouldn't say such in a full term. Okay, so thank you very much.